Solving advanced simultaneous equations by elimination. So, what we have here is a situation where we cannot just make one letter the same as the other letter by just multiplying one of the two equations. So, what we're going to do here is, since this is 5y and this is 3y, if I multiply the first equation by 3, I'd get 15y's, and the second equation by 5, I'll get 15y's, and then we'll have the same number of y's in both equations. So that will enable us to eliminate. So we'll do equation 1 and we'll multiply that by 3. That would give me 9x's and 15y's, and that would be equal to 18. Let's call this one equation 3. Then equation 2, and multiply that by 5. That's going to give me 10x's and 15y's is equal to 25. Let's call that equation 4. Now we can see that we now have the same number of y's. Now remember, same subtract, different add. Same subtract, different add. So 15y's, it's the y's that we have the same number of, and the signs are the same, and that means signs are the same on the letter we have the same number of, so we subtract. So I'm going to do equation 4, take away equation 3, 10x take away 9x is a single x, the y's disappear, that was the whole point, 25 take away 18 is 7, so I have x is 7. I'm going to substitute that back into equation 1. If x is 7, 3 7s are 21. So 21 add 5y equals 6. Gives me 5y is negative 15. And then y would be negative 3. So my solution is x is 7. Y is negative 3. Now, if we want to get the same number of y's, multiplying the top equation by 2 will give me 10y's, multiplying the bottom equation by 5 will give me 10y's. Note where I get that from. I've got 2y's in the bottom one, so multiply the top by 2, 5y's here, so multiply the bottom one by 5. So, if I do equation 1 and multiply that by 2, that gives me 12x minus 10y is equal to 8. The bottom equation by 5 gives me 20x's, add 10y's is negative 40. So we have 10y's in each equation, but the signs are different, so therefore we're going to add. So if we call that 3 and that one 4, we're doing 3 add 4 here. So that's going to give me 32x's. The y's disappear, is negative 32. And then x will be equal to negative 1. Let's substitute that into 2. Doesn't matter which of the original equations we go back to. So if x is negative 1, that's negative 4. Add 2y is negative 8. So 2y would be equal to negative 4, and y will be negative 2. So we're saying that x is negative 1, y is negative 2. I used equation 2. Let's check that that works with 1. So that would give me negative 6, add 10, which is 4. So that's correct. Now, equation 1, equation 2. If we multiply the top equation by 3 and the bottom one by 2, we'll end up with the same number of y's. So 1 multiplied by 3. 3 times 17 is 51. So I'm going to get 51 x's minus 6 y's. 3 times 47. So 3 times 40 is 120. So it's going to be 141. Let's call that one equation 3. And then 2 multiplied by 2 gives me 10 x's. Take away 6 y's is 18. Let's call that 4. So we have the same number of y's, 6 y's, and the signs are the same, so we're going to subtract. Equation 3, take away equation 4, so that gives me 41 x's is 141, take away 18. Just quickly do that over here. So 3, 2, 1, 2, 3. And then I can see that x is equal to 3. So let's sub that into 2. That looks like the easiest equation to work with. So if x is 3, that's 15 minus 3y equals 9. So negative 3y is going to be negative 6. So that gives me that y is 2. So x is 3, y is 2 appears to be the solution. Let's check that in 1. If x is 3, that would be 51. Take away 4 is 47. So that works.